We're going to start section 2.4, which is an introduction to factoring. In part A, we're going to factor out the GCF, which is the greatest common factor. So if I look at these values, 24 and 30, I want to find the GCF. So first of all, GCF is greatest common factor. So I'm looking for the largest number that divides evenly into both of them. So 24 and 30, the greatest common factor is going to be 6. 6 is the largest number that you can divide evenly into both 24 and 30. If you're looking at 12, 15, and 20, the GCF is just 1. 1 is the only number that divides evenly into all three of those. If you're looking at the next couple, they have both variables and constants. So if you look at the constant part first, 9 and 15 can both be divided by 3. And then for the variables, you have enough a's to have a squared in both of them. So you're going to actually use the smallest variable every time because a to the fifth is made up of a squared times a cubed. So both of them have at least a squared. So the next one, 8 and 24 can both be divided by 8, and x to the 7th and x to the 5th can both be divided by x to the 5th. 6, 10, and 15 can only be divided by 1, but n to the 6th, n to the 5th, n to the 4th can all be divided by n to the 4th. I don't need to write the 1 when it is the coefficient of a variable. Last, 4, 16, and 8 can all be divided by 4. Each of these has at least one x and at least y squared. So you can divide by 4x, y squared. So the GCF of a monomial, each of these terms up here is a monomial, is the largest number, or the largest numeric divisor of all the terms, and the exponent, or the variable with the lowest exponent in any one particular term. So the variable with the lowest exponent. Any other terms. All right, so what we're going to do in the next couple is we're going to identify the GCF, the greatest common factor, and then we're going to factor it out. So first, identify it. I'm just going to write my GCF up here. 20, 12, and negative 28, those can all be divided by 4. And they don't share a variable, so just 4. Now we're going to factor it out. So I'm going to factor it out by writing the 4 outside of a parenthesis and inside the parenthesis, what you get when you divide that 4 out. So for example, 20 divided by 4 is 5x, 12y divided by 4 is plus 3y, and negative 28z divided by 4 is negative 7z. So what we're doing is unmultiplying, undistributing when I factor. Okay, so back up here, factoring is the opposite of distributing. So when I finish factoring something, it should look like something that I would be able to apply the distributive property to get back where I started. Notice that if I distribute the 4, I'll get back where I started up here. This has been factored. We're going to continue to factor in the next one. Look for the GCF. Greatest common factor. Now, both of these terms are negative, so my GCF certainly will be negative. But anytime the first or leading term is negative, we always factor out a leading negative. So make that a note of that. Always factor a leading negative. So my greatest common factor is going to be negative. 15 and 25 can both be divided by 5, so negative 5, and it also needs to have n squared. So I'm going to factor out negative 5 n squared. If you divide negative 15 n to the third by negative 5 n squared, you're going to be left with 3n. Negative 15 divided by negative 5 is positive 3. N to the third with 2 n's removed leaves you with 1 left. Negative 25 divided by negative 5 is next. That's going to be plus 5. And n squared, the n squared has been removed, so just plus 5. You can always check by redistributing to make sure that you get the original. Okay. In the next one, instead of writing my GCF at the top, I'm just going to write my GCF as I begin factoring. So I see 8, 30, and 6 can all be divided by 6. So I'm going to have 6 times 18, 18, 30 and 6, 18 divided by 6 is 3. X to the third minus 30 divided by 6 is 5. X squared, and last, plus 6 divided by 6 is 1. I wasn't able to take any of the variables out because there was no smallest variable term that all terms shared. Just 6 for the GCF. Part D, 16, 10, 8, they can all be divided by 2, so I'm going to factor out a 2. For the A's, 3, 2, 4, so the smallest power is 2. For the B's, smallest power 1, 3, 2, 1. So we're going to be able to factor out 2, A squared, B. If you divide that out of the first term, 16 divided by 2 is 8. 2 A's removed, 1 left. B removed, no B's left. Minus 10 divided by 2 is 5. A squared's both removed, 1 B removed, B squared left. Minus 8 divided by 2 is 4. 2 A's removed, 2 left, so A squared. 1 B removed, 1 left. So that would be factored. And the last two. Example 2, I want to factor out the binomial GCF. So the binomial GCF, 3x times 7n plus 2 and 5y times 7n plus 2, they both have 7n plus 2 in common. So we're going to factor out the 7n plus 2, just like we factored out the 5n squared up here. So it's going to leave me with 7n plus 2, that's what's in common. Factor that out. When you remove that from the first term, that leaves you with 3x. When you remove the 7n plus 2 from the second term, that leaves you with plus 5y. So this is now factored. Once again, in part B, these have a binomial instead of a monomial in common. So a squared times 4b minus 9 minus 2 times 4b minus 9, they both have 4b minus 9 as the thing that's in common. When I factor that out, remove the 4b minus 9 from the first term, it leaves you with a squared. Minus, in the second term, removing 4b minus 9 leaves you with negative 2. That's considered factored. This is factoring out a monomial GCF in part 1, and in example 2, we factored out a binomial greatest common factor. That's the end of part A.